Hello, I'm Dan from New York, and I'm going to talk a little bit about digesting event data at JW Player. What I'm going to talk about today, first, who is JW Player, just a little bit of background about who we are as a company, and then diving right into how we collect events, how we process and crunch these event data, some ways we can make use of this event information, and then if there's time, a little bit of Q&A at the end. So, who is JW Player? Well, we're sort of a mix of different things, right? We've got the JW Player, we've got the platform, we do some media hosting and things like that. We're trusted by over 10,000 media brands, 600,000 domains around the world, and we actually get over 2 billion unique monthly viewers across our network. So JW Player is positioned kind of interestingly because it's got this video player that all these organizations are using to serve their media content. And data has really become core to our strategy. So we started out as just kind of the fastest online video player, as we'd like to believe, in 2008. Started doing some video management and delivery, hosting people's media for them in 2011. Did some analytics. We started realizing publishers were really interested in understanding who's watching their videos, what videos they're watching, other things like that. So we kind of moved in that direction in 2014, and then 2016 and beyond up to today, really moved into a data-driven product and decision market. And that's what I'll be talking about primarily. So, talking about data, right? Like, how are we collecting this data? What data are we collecting? So at a glance, we collect a lot of data every single day. We're talking billions of events, terabytes of data, and millions of play sessions. I'll talk a little bit about what a play session is in a few minutes, but for this slide, I just want to sort of highlight that we're compressing 2 billion kind of raw events down to 250 million play sessions. So keep that in mind as we go forward. So we're talking a lot of data, right? We're like, it almost feels like we're in the Matrix. We're just like numbers are flying down the screen. It's unbelievable how much data we're processing. So what data are we talking about, right? How are we collecting this information? So we have a JavaScript plugin inside JW Player. We call it the Ping plugin. And again, JW Player is a video player, right? And so it's got this plugin, and it sends back event information as a query string. And pings are basically sent back for all sorts of events that are taking place in the player, such as when the player is embedded, so sort of when it appears on the screen, or on the page rather, when the viewer starts playing a video, when an ad is requested, and many, many more. So I've got an example kind of at the bottom here of one ping that the player would send back, or really that the plugin would send back. So you can see that there's sort of a lot of different parameters that are sent back, right? We've got like an H parameter and an E parameter and an ABC and an AID and all this stuff, right? So this is identifying information about the video that was playing, the publisher that was playing it, the viewer, and all sorts of other things. And so we're collecting all of this data. So you can imagine if we have billions of viewers every month, and each one of them is generating even 5 of these pings, we're talking, many, many billions of events every single day. So once again, we're talking, I figured I'd go with the Matrix theme here. How are we collecting all this data, right? So we've got this sort of auto-scaling group in AWS. I'm not sure how many people are familiar with this, but basically we've got servers that scale out, much like Agent Smith did when he's fighting Neo, in order to support all of this incoming data. So each server basically is running just a little Nginx server that collects all this incoming ping data and then writes it out back to AWS S3. So a little architecture overview here, just to kind of summarize what we've talked about thus far. Got the Ping plugin here on the left inside of the player, sending player events, as we've seen, those kind of query string parameters things. We've got this sort of auto-scaling Agent Smith ping node group, and then we've got raw logs on the S3 side. So S3 is kind of a data store on AWS that allows us to collect all of this information into one place and then kind of pick it up and process it from there. So how do we process the data? We have what's called the Ping Parser. And again, we're kind of talking about events kind of interchangeably with pings. They kind of mean the same thing in JW player parlance. And basically what this is a Hadoop map job. We don't do any reduction here, just a map job that picks up the raw logs from S3 and enriches each event by adding page domain, geo information, and other kind of ancillary information. So it's this job that's picking up the raw logs and kind of taking each ping and enriching it, and then writing the results encoded as something called Avro, which is a binary data store format, back to S3. And we have this idea of a batch. So it's a little diagram here. Hopefully this helps a little bit. Basically, we've got the raw logs here on the left-hand side, and then some number of pings, and we have these kind of curly braces around each set of pings, which becomes a batch that the ping parser kind of creates, picks up, and then writes back out to S3 as parsed pings, as we call them. And again, these parsed pings are encoded in Avro format, which allows us to process them further downstream. Avro also gives us some schema enforcement, and the ping parser also gives us, kind of this data enrichment quality. And so where do we go once we've got these parsed pings, right? We've got them now written out back as Avro. What do we do? Well, we generate what's called a play session. And so you can imagine this diagram kind of extending from the last one. Now we have parsed pings on the left-hand side. And notice here I've kind of waved out a few pings here, and they all have this P parameter, which is AB1. So imagine we've got all these pings coming in that are from the same kind of play ID. So we have this play ID AB1. Some viewer has come and watched some piece of media, and we're interested in kind of compressing that data down into a single unit. And the way we do that is we compute what's called play sessions. So we have a little app called the Sessionizer, run on EMR, which is another AWS service, basically a cluster of machines using Apache Spark. And we compute a play session for this particular play ID. So we can take 5 or 10 or 100 of these pings and compress them down into a single unit called a play session. So once again, Sessionizer, as we call it, is a transformation and aggregation query, hundreds of columns long, that runs on Apache Spark, EMR. And essentially what we get from this is a 90+% compression rate. So we can take terabytes of data and compress it down to gigabytes of data. And what that does is it allows us to run queries against it and start, making some really informed decisions in a really kind of meaningful way, whereas with just the ping data, we wouldn't necessarily be able to do that, right? So play sessions give structure to the event data and essentially answer the question, what actions did a given viewer take while watching a given piece of media? So this is really important, right? Because when we have all these kind of streaming event data coming in, we don't really have a way of giving structure to it on their own. But when we compute these play sessions, now we've got something meaningful. We've got something that can tell us what's happening for a given play on a given piece of media. And so we do things on the aggregation side, like count up how many times someone seeked in the video, or we count up how many times someone stopped and started the video, or we measure, whether the player was muted, or how often the player was viewable on the page for that given play session. So you can imagine all these kinds of things in aggregate in a single row of data. And so now that we've got these play sessions, right, how do we actually use them? What do we use them for? So one of the things we do that we're really excited about and continuing to kind of evolve as we go forward is A/B testing. And just to give a quick summary in case people aren't familiar, A/B testing essentially means that we're showing some viewers one variant and some viewers another variant of something in the player. So two people might be seeing some different UI element, for example, where we say, oh, this UI element should appear in the top left corner, and some other people will see the UI element in the top right corner. And then we can measure which one of those performs better. So we have this plugin, again, that's sending info back about what scenario was seen. So we'll be able to tell from a given viewer whether they saw it in the top left or top right corner. And then using play sessions and some other data crunching techniques, we can learn which variant performed better, right? So we can measure things like click-through rate, completion rate, total viewer time. For example, did someone click through to the next video? Did someone complete the video? How long did they watch the video for? Right? These are all really meaningful metrics that we can measure, and by A/B testing these kinds of things, we can guide new feature development. So should the UI element, maybe it's like a little X or a play button or something, where should that really go? Well, we can use data to tell us where it should go, rather than guessing, or rather than thinking that we know what's right. We can test all of these different scenarios and learn what's correct. And so a couple of examples. One is a project worked on by kind of a data science team at JW called Intelligent Thumbnails. So we see here kind of in the top left a few different possible thumbnails for this video. Someone may be riding a bike down Route 1. And there's some neural network figuring out which thumbnails would be best for this particular video. And you can see here that each one of them has a given score that was assigned based on some neural networks, deciding what was the best thumbnail. And here, this thumbnail has won out, right? It's got the highest score. But this other thumbnail, which is kind of obscured by the video, has a really close second, right? 85 versus 82 here. And so we might say to ourselves, well, which thumbnail should we be showing? Or let's say two different algorithms produced those two different thumbnails. Which algorithm is better? And so once again, going back to the idea of A/B testing, we can show some viewers one thumbnail and some viewers the other thumbnail, and then learn which one gets them to click on the next video, right? Which one gets people more interested in watching the next video. Another way we use this is in generating recommendations, so building media associations. You can imagine, again, that there are viewers who will watch a cat video, and then they will go on and watch another cat video. And then they'll probably watch a dog video, and then they'll watch some cute squirrel or something, and then they'll go back and watch another cat video. So how do we measure that? How do we understand that? So we can see that there's some people, say these orange people, watching video 1, and then there's these blue people watching video 2. And then there are these green people who have watched video 1 and video 2. So this allows us then to compute recommendations, to figure out, like, what video should we be showing to someone or suggesting someone watches after they've watched that really cute cat video and they're like, oh man, I really want to see another cat video. Well, we can actually suggest that to them. They don't have to go find that video. We'll show it right to them. And here's a little example of what recommendations looks like inside of JW Player. So you're watching this video, and then you've got the more videos come up in the bottom, and you can actually select another video from that list. So we're seeing here, someone's clicking through and saying, oh, well, I'm watching this cool foggy glass thing, so let me go watch some fog somewhere else. I don't know. It's not quite the same as cats, but it works. So basically, you've got this idea of recommendations, right? So this is another use of data. And once again, going back to the idea of A/B testing, we can test out different recommendation algorithms based on this idea of A/B testing, right? We can show some people one set of recommendations, so some people another set of recommendations, and say, okay, which one got more people to click on the cute cat video or like this other foggy video from this first foggy video? And just to wrap things up here, I want to talk a little bit just about publisher analytics, right? So we can do all this cool data science-y stuff and like make algorithms smarter and machines can take over the world. But before that happens, we can, as humans, run queries on the data, right? We can, because we've compressed the data down so much, we can actually run queries, meaningful queries against the data and get results back quickly. And play sessions, as I've talked about, allows us to answer all sorts of questions about viewer behavior, right? So we can understand things about quality of experience, like time to first frame and bit rates and buffering, how often people are experiencing buffering, for example, or how long it takes them to get to the first frame. We can understand things about feature usage, which sort of ties in back to the A/B testing again, but more so also about like, you know, there's so many features inside of JW Player and like which features are being used, which ones are not, and you know, begin to understand how people are interacting with the player. And we can also understand, broadly speaking, who our viewers actually are. And I say broadly speaking because it's worth noting in this day and age of like data leaks everywhere that we're doing this sort of on aggregate. We're obfuscating things that would allow us to tie information back directly to a viewer. But we can understand things like this video was watched by people in Canada, but not necessarily people in the US. Why is that, right? Start making decisions on aggregate about who our viewers are and why, perhaps, why they're doing the things they're doing. So all of this is coming back, just to tie it all back together, from the Ping plugin, from event data being emitted from the player that we're then processing and using to make all these cool decisions and cool algorithms and just ultimately, at the end of the day, providing a better experience for people who are using JW Player. Thank you. When we show recommendations, how many are we showing? I think in general we show somewhere in the neighborhood between 5 and 20. I don't know exactly how many. I don't know exactly because I'm more on the data engineering side than the data science side, but I'd imagine you'd need something around at least 1,000 assets. And if you're interested, we can touch base afterwards. I can actually get you like an exact number. But I'd imagine, yeah, you need some sizable number in order to train the algorithm well enough to get some meaningful recommendations to be generated. In general, we try to guarantee our data, let's say, within 2 hours. And realistically speaking, we've probably got it down to more like an hour, but to give ourselves some headroom, we're talking more like 2. But essentially, yes, between all these different computations, and there are things happening even more downstream of play sessions that I didn't quite touch on, it does take at least, let's say, an hour from the time a ping is emitted to the time that it can actually be surfaced or consumed by something downstream. There's a separate track, which I haven't talked about at all here tonight, which is real-time processing. So there are tools like Apache Flink that allow you to do real-time streaming of this data, and then you can knock that time down from, say, an hour to something like 15 seconds. So there's some really powerful stuff out there, but for this, yeah, we're talking more about batch pipeline. Yeah, it's about an hour. Currently, it is within the publisher. So a single publisher, you're watching one video, you'll be recommended videos from that publisher. I believe there is some work going on to, as you say, expand that so that you can actually recommend a different publisher's video. But again, not being particularly well acquainted with that, I'd imagine that there could be some friction between a publisher saying, well, why are you showing a video from this competitor? Right. At this point, the recommendations are built more around the media than the viewers. So again, as we go forward, we might be able to incorporate more viewer information, but for right now, it's based more on the media than the viewer habits themselves. We surface a lot of this information. We basically take play sessions and surface it to publishers. So there's lots of metrics in there. But as you say, there is the 1 hour latency. So we have a few small things right now that we're kind of working on expanding that leverage something, again, like Apache Flink that allow you to take these real-time kind of streaming data and surface them within seconds. So I believe right now, excuse me, we have something like a 1-minute guarantee on the real-time data. So in that scenario, and as we build that sort of system out, we will be able to sort of give things to publishers where they can take action because they'll know within a minute what's happening within their network.
It's not available yet.
Not quite there. There's some pieces of it are, but by and large, a lot of it is still in the batch pipeline just because it gives you a lot more like heavyweight processing power. So it's kind of more challenging to build that in real time and actually surface that in a minute, let's say. Yeah.